Hi, today we will be talking about matrices. We have chosen the set H. So what we will be doing is we will be given 3 codes that we should inverse to find in order to use it as a key to decipher a code given to us. And then whichever key unlocks is able to decode will show the message intended for us. That's all.
Assalamualaikum and hi madam. My name is Nur Saada. So I will explain about adjoint method for the K1. We have K1, K2 and K3, so I will explain for K1. Okay, we have 5 steps to get the inverse of matrix for adjoint method. First, we will find matrix minor. Second, we will find matrix cofactor. Third, we will find adjoint A. And fourth, we will find determinant. And lastly, we will get the answer, which is inverse matrix. So let's start. So the given matrix is 4 by 4, which is 3, 1, 4, 3, 2, 5 to get this matrix. So to get matrix minor, we will start for the first row and first column. I choose this and this to get the first one. So when the first row and first column like this, so 5, 3, 1, 1, 2, 1, 2, 2, 5, I will get for the first one, this one, which is 5, 3, 1, 1, 2, 1, 2, 2, 5. Okay, this one I insert in this. Okay, for the second, which is this one, it is for the second column. Okay, if I choose the second column for the next, yes, of course the second column, I choose this, but the row is maintained. So I will get 2, 3, 1, 1, 2, 1, 5, 2, 5 for the second one. Okay, this is for when it goes from left to right, the column moves. But when it goes from up to down, the row will move. Okay, for example, for the second one, which is this one, 2, 5, 3, this one will move. So I got this, which is 1, 2, 3, 1, 4, 3, 1, 2, 1, and 2, 2, 5. This one we were not take this, but I just take this one, and this one, because the row moved from up to down. Same as this for the third one. So for the third one, 1, 4, 3, 5, 3, 1, 2, 2, 5. This one we will not touch. Okay, so overall, and then I got this one for the matrix minor, but it not end yet because we must find the second step for the last. Okay, this is come from this one, the first one, 5, 3, 1, 1, 2, 1, and 2, 2, 5. This, okay, how to get the exactly answer is actually from this step. Okay, I will take out the first row, 5, 3, 1, this one, 5, 3, 1. Okay, and then 5, this for the first column and first row and the first column. Okay, how do I get this one? This is the product from 2 times 5, 10, and then minus 1 times 2, minus 2. Okay, and then minus. Okay, this is because positive, negative, and positive. Positive, negative, and positive. This is the step for the calculation. That's why I got this one. So the third, this is for the 3. Okay, how do I get this? I got from, okay, because it is 3 for the second column, so we cannot touch with these 2. So the product, the multiply product is 5 times 1 minus 1 times 2. So I got this one, the product, and then same as for this, the last one. 1 and then 1 times 2 and minus 2 times 2, 4. And then overall, I got 29 and I insert for the minor. This is just for the first one. And same as all over, for the next step, I choose this and I will do it all over again, and I got 7. And then minus 1 for the this, and this I got 20. So overall for the minor, I got this answer for the adjointed matrix minor. Okay, thank you.
Okay, so for the next step, we will be finding the adjoint A. In order to find the adjoint A, we first need to use the cofactor that we have found earlier. And then in order to find it, we have to first change the first row into the first column, the second row into the second column, and then so on. So, based on the cofactor that we have found earlier, we simply just change the first row into the first column. So, first row into first column, second row into second column, third row into third column, and fourth row into fourth column. Then we get the adjoint A. Right, for the next step, we will then find determinant A. So, in order to find determinant A, we need to choose one row or column from the original matrix and from the cofactor matrix. So, in our calculations, we have chosen the first row and the first row for the original matrix and the first row for the cofactor matrix. Then we should multiply it. The first number, multiply with the first one, then the second with the second, and then just add all of it, and we get the answer. The next, in order to find the inverse, the formula is 1 over determinant A times the adjoint A, which we have found earlier. Then just insert all the information that we have found. Okay, and then after multiplying both of them, this is what we get for the inverse. Then the inverse will then be used to decode the actual code.
Okay, so let's continue with the second matrix given. In this second matrix, we are required to do the inverse matrix of this matrix by using ERO method. Okay, so the first step to change this matrix into ERO method is by adding the identity matrix beside the matrix given. So the matrix that we added must have this kind of pattern, which is 1 0 0 0. Can you see this? It's like this. Okay, so after that, after we add this inverse matrix beside this matrix given, we have to change this matrix given into this kind of pattern, which is this kind of pattern. Okay, so in order to do that, we have to create our own formula like this, so that this one can be like this one. Okay, so but before we change this matrix into this one, we have to do it in order, in correct order. Which one? This one first, second, third, and so on. Okay, so first change this one into 0 first. First, the second. Okay, so I want to change this one first into 0. So how can I do that? Okay, so first, this one I might multiply it by 2, and when I multiply this by 2, this whole line we have to multiply it by 2 also. So after we multiply this by 2, then we decide to subtract this row 2 with this row 4. So this is what the formula. We have to multiply it with 2, row 2 multiply it with 2, and then minus row 4. So this is the result from the formula. So we got 0, 0, 8, 7, 0, 2, 0. Okay, so now we managed to change this one into 0. So apply that formula until all this matrix become this one, this what we call that lower triangle matrix become 0. Okay, so after we do that, this is the formula that we come out with. Okay. So I will continue with Alia. So basically, Alia has said that we should use this formula, or maybe you can create your own formula. So by using our formula, we came out with the last one. So the last one, we did this one. Okay. So we choose to make the R1 to become 0. We tried to make the top one to become 0. So by trying to do that, we need to make it come into 0. So after the matrix that we got after this, use the matrix that we got after this formula, we got this. So we need to subtract R1 row 1 with row 5 row 2. So basically all the row 5 is being row 2 are being multiplied by 5. Okay, and then after we subtract it, and then we got 0, 0, negative 21, negative 16, 1, negative 5, 0, 0. Okay, then we can come up with this matrix. So basically when we came out with this matrix, we are become lost. We doesn't know what to do, because actually we need to turn this one into 0, but we doesn't have any other numbers to be subtracted with that person. Okay, basically this thing happened, person or number. Okay, basically this thing happened because the determinant is 0. Actually when we try the other formula, some of these determinant become 0 also. Which one? Which this is? This one. Okay, so basically this happened because you can see, actually you can know that at first, you can know that this method is not suitable because you can see 5, 5, 1, 1, 4, 4, 2, 2. So and how you subtract or you plus or you multiply or you divide it, you will get both of the number 0. So basically, actually you need to get this one, but you will get all the number 0 because it has the same numbers. Okay. So when the determinant is 0, it means there is no inverse. Determinant is 0 means no inverse. No inverse. So basically, the matrix 2 is not suitable at all to enter the code because it could not be inverse. Okay, that's all from me. For the third code, we have a choice of either using the ERO method or the agile method. We chose to use the agile method because we find the agile method is easier to use. Then from the first code, we have learned how to do the agile method. So here's a quick recap. First of all, we need to find the matrix finder from the code into the matrix finder, and then after we calculated it, we got this.
And then from the matrix finder, we find the matrix cofactor. According to the according to the first code, we have already explained about what formula to use in order to find this matrix cofactor. And then after finding the matrix cofactor, we switch the row and the column to get the adjoint A. That's it.
Okay, so for the next step, we must find the determinant. So to find the determinant is pretty easy because we just need to multiply the original matrix and the cofactor that we have found. So we just need to choose one row. So I choose the first row. So we get this. So the last step is we need to find the inverse. For the inverse, we just need to multiply the 1 over determinant and the adjoint. So we get 1 over 20 times with the adjoint that we have found earlier. And then so we get this.
The last step to find the code is to multiply the code matrix and key matrix. And then the answer cannot be decoded into letters because the codes provided are positive numbers. Next, we will try to use K3. Okay, the same method like I had mentioned earlier. Multiply the coordinate matrix and inverse key matrix K3. Okay, the answer is the message. To convert it into letters, we refer to the list given.